Hi, everybody. In this next section, we're going to look at the distance and midpoint formulas as well as circles. So let's start with the first part. So we do have a distance formula that will tell us the distance between 2 points in the rectangular system. And we do need the formula. So when points are right above each other or right next to each other horizontally, we're able to count. So we were counting a lot when we were doing slope and things like that because we were counting just straight up or straight over left or right. But if points are actually diagonal from each other and we're trying to find the distance between them, it's actually quite difficult. We can't just count. And we have a formula called the distance formula, which is actually used and found using the Pythagorean theorem. So if anybody's interested, you can look further into that. I'm just going to use the formula today, but it is derived from the Pythagorean theorem, which is when you have that triangle and it says a squared plus b squared equals c squared. So that's where it comes from. So let's apply it here. And we apply it between 2 points. So here's my first point, here's my second point. It doesn't matter which point you call point 1 or point 2, so you can just pick one. And we just plug it into our formula. So D stands for distance here. So what you do is you subtract your X values. So let's see, my X values are 3 minus, and then I have -1. I subtract my Y values, so -2 minus 4, and then I square both of those subtractions. Be really careful here. You have minus signs in the formula, and then you also have a lot of negatives. So watch out there. You're going to use order of operations, simplify inside first. So here I end up with 3 plus 1, which is 4. So I have 4 squared. And then here, -2 minus 4 is -6 squared. Now, 4 squared is 16, and -6 squared is 36. When you square, that negative in the end will cancel out. It's -6 times -6 is positive. And then we're going to go ahead and add these together, and we get 52. Now we're going to express our answer in simplified radical form, and then we're also going to round it. So just remember that you want to try to break this down as much as you can. So 52 is not a perfect square. But if I think about 52 and I think about some factors there, factor pairs, I do have 4 times 13. And that 4 is a perfect square, right? It's 2 times 2. So I actually can go ahead and break this down as √4 times √13. And then √4 is 2. So in simplified radical form, it would be 2√13. Now on your calculator, I'm just going to bring my calculator up right here. What I'm going to do, remember this is multiplication here. So this is actually 2 times √13. So I'm just going to do 2 and then times, and I'm going to use my square root key here. So square root of 13, and it looks like this. And then I'm going to go ahead and hit enter. And I have about 7.2111. And I do want us to round to 2 decimal places. So I'm rounding there. So it's about 7.21. And this would be in units. So if we're just on a grid then and we don't have actual units specified, then we would just do it in units. If you have units specified according to like an application problem, then you would just use those units that are given there. So here you have an answer. I would definitely try your calculator at home. So try your calculator, particularly if you have a different one, and make sure you know how to use it. You know the answer here should be about 7.21. So try your calculator, figure out the steps until you know how to actually enter your roots and simplify to get the answer. Now, this one didn't say to graph, but I just want to show you really quick kind of what is happening here. I'm just going to go by ones. All right. So my first point is -1,4, which is about here. And then my second point is 3, -2. Again, I know this is not perfectly to scale, but just kind of want to give you guys an idea. So what we're finding here is the distance of this line segment. So this is the distance that we just found. So it's basically the length of the line segment between these two. Okay. So the length of the line segment between the 2 points is equal to the distance between the 2 points. But sometimes it's a good idea just to think of it this way as a line segment, particularly for applications and things. So if you're asked to find the length of a line segment, then you could be asked to actually find the distance between those 2 points and vice versa. So it's nice to have kind of a little bit more of a concrete way to think of this. Now, the second formula we have is the midpoint formula. And this formula here tells you the midpoint of that line segment, or the halfway point between those 2 points. So the midpoint is the halfway point between the 2 points. And I want to use the same 2 points that we did in the example above, and just show you how to use the formula here. Basically, you're just averaging the x values and the y values. So the example was -1, 4, and 3, -2. So here was x1, y1, and x2, y2. So the formula here, I would do x1 plus, actually, why don't we write it out first? x1 plus x2 over 2, and then y1 plus y2 over 2. This gives you a point. So it's not a value, it's a point on the graph. That's why you have the parentheses and the comma. So it's -1 plus 3 over 2. And then for my y values, 4 plus -2 over 2. -1 plus 3 is 2. So I have 2 over 2. And then 4 plus -1 is also 2. So the point here ends up being 1, 1. And that's my midpoint. Now let's look at my graph from above, and I want you to see that. So if I find 1, 1 on my graph, it was here, 1, 1. Again, my graph isn't totally perfect because I just kind of drew it fast, but you can see that that point is supposed to be right on the line segment, but that point is halfway between those 2 endpoints, right? This is the midpoint. And you can see it cuts it in half, right? So this is half the distance, and this is half the distance. So again, it's just a nice way to think of it, as well as it's cutting that segment in half there. So it's the halfway point between the 2 points. And it's also the halfway point of that line segment between the 2. And again, this can kind of be helpful sometimes in applications if you think of it that way instead.